I want to introduce you to somebody. This is Grace Hopper, and she's every bit of a badass as she looks in this photo from 1984, and in 1978, and in 1960. She was a computer scientist and a rear admiral in the United States Navy, and she pioneered this crazy idea that programming languages should be machine independent, and that computer languages should be able to use understandable words rather than these cryptic codes and numbers. And this ultimately led to the development of COBOL, which was an early high-level programming language that's still in use in plenty of places today. Back in 1944, Grace was one of the first programmers on this monstrous computer known as Harvard Mark I, and later its predecessor, Harvard Mark II. On September 9th, 1947, when Grace was working on the Mark II at Harvard University, one of her associates discovered that a moth had become stuck in one of the mechanical relays, impeding its operation. Ever the clever one, Grace and her crew dutifully taped the offending moth to her logbook, and for many years, people have attributed the invention of the term bug or debugging in the context of computers to Grace. Sadly, this is a misconception, as the word bug had been around many, many years earlier in engineering circles to mean just some sort of problem in the works that needs to be figured out. But Grace did get a destroyer named after her, the USS Hopper. Grace passed away in 1992 at the age of 85, but her impact on modern computer science still lives on, and it enables a lot of the cool things we can do today with software development. So we're going to talk about CI/CD and also CD. First, continuous integration, and that just means we're going to be merging code changes back to the main branch as frequently as possible. And ideally, we're automating the testing as we go, so we instantly know if we break the build, for example. Continuous delivery means that we have this automated process to get everything ready to release, and we can trigger a release just by pressing a button, for example. Now, continuous deployment one-ups that slightly because now we automate the entire chain. So every time a code change is committed and it passes all the stages of testing, it gets instantly released into production with just no human intervention. Let's take a look at a common software development lifecycle. First, you would get the latest from the software repository. You'd make your changes, maybe you do some unit testing, you'd commit it back to the repository. And then there's a series of integration testing that goes on once it gets committed. And then you maybe have acceptance testing, and you can deploy to production. And then after you deploy to production, you usually have this concept of smoke testing, meaning you test it once it's out to production just to make sure it deployed okay. Now, many software shops do all this stuff completely manually. Manual unit testing, integration testing, and acceptance testing. They deploy to production manually, and they manually smoke test. So if we implement test automation, what we can do is take the human element out and then make things more streamlined. So this loop here, shaded in gray, is what we define as continuous integration. Several times a day, we're getting the latest copies from the repo, we're making changes, and we're checking it in, and it goes through automated testing. And so for continuous delivery, we can push that button to deploy to production as frequently as once a day. Whereas back when we had manual processes, maybe we could only deploy to production weekly or monthly because of the overhead involved in testing all the parts and pieces. The next evolution would be a continuous deployment scenario where we completely automate the deployment to production, and it gets triggered after all the tests pass. Now, there are some considerations that we have to note when we're talking about CI and CD. First, the objective is to really create these small, discrete packages that get implemented very regularly, rather than creating these large, complex changes. And what that does is it lowers our deployment risk. So we're not deploying this huge code base, we're deploying these little chunks of code. And if something negative happens, it's isolated to that little feature. Now, for very efficient CI and CD deployments, your test automation game has to be really strong, meaning that you have a nice suite of test scripts that run automatically, because really those test scripts are the only thing standing between your new code change and production. So traditionally, if you were working on a feature that's not ready for deployment into production, maybe you'd create a branch and then merge it down the road later. Another way to do that is use this concept called a feature toggle. And this allows you to wrap your new feature into some sort of logic condition that allows you to switch it on and switch it off. So although the code may get deployed to production, it's not active until you intentionally make that decision to switch it on. And microservices really lend themselves well to CI/CD because by their definition, microservices are very small services that are very discrete in nature. AWS has a lot of good tools to help us with this deployment method. CodeCommit is a hosted Git repository. CodeBuild helps us compile code, run tests, and create deployment packages. CodeDeploy can deploy these deployment packages on EC2 or Lambda, Elastic Beanstalk, or Elastic Container Service, or even on-prem systems. CodePipeline is the orchestration mechanism that helps us do all these things together. Debugging in a distributed application or in a serverless type scenario is sometimes really difficult, and Xray is a really nice feature that helps us do that debugging. CodeStar is to our development processes kind of like what Fargate is to the Elastic Container Service. It's a service that leverages all these other services and creates some templates that are more turnkey, and you don't have to create all these things manually.